Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-6 Extra Practice number 3 solutions on exponential equations with the common base method. For this one, we have a puzzle to solve. Let's take a look at that. For this puzzle, we're trying to figure out why was Papa Shoe mad at his son. So to do this, we have to solve each of these equations, and then the answer matches a letter that we're going to put above whatever the question number was down in these blanks below. So for number 1, let's say that I get answer W for some reason. That would mean I put a W here. I don't think that's what it is, but hey, let's find out. So here we go with our first problem, 3 to the x equals 253. Now all of the problems on this puzzle can be solved using something called the common base method. The idea behind this is that you want to get some number to some power on each side of the equation, and then you can cancel out the bases and set the exponents equal to each other. So all of these problems could be solved using logarithms, but often those solutions are kind of more the long way around. Common base is faster when we're able to use it. So in this case, I need to find my common base. We've already got a 3 over here. It's not going to get much simpler than that. 243 is a power of 3. This is really 3 to the 5th power. So I can rewrite this as 3 to the x equals 3 to the 5th. And then I can cancel out those common bases of 3 and then just write x equals 5, which solves the equation. So 5, let me find that over here. That's going to be a, so we'll put an a in spot number 1. And just double checking here, it doesn't look like there's any duplicate sort of numbers down here. So each of these should go in only one blank. Next up, number 2, we have a common base of 2 to the x, and then 1 over 16. I could think of that as 1 over 2 to the 4th, and I could think of that further as 2 to the negative 4th. Now that I have a 2 as a common base on each side, I can just essentially cancel out the bases and write x equals negative 4, which is the answer. So that's going to be O going in spot number 2. Here we go with number 3, where the common base is actually also 3. So I can rewrite 1 over 3 as 3 to the negative 1, and I'm going to leave that x outside the parentheses for now. I'll deal with it in a minute. This 3 over here is already as simple as it gets, but I'm going to write it as 3 to the 1, just so I have something in the exponent to set equal to when I cross off the common bases. I do need to clean up this left side a little bit, though. So if I'm raising an exponential expression to another exponent, I just have to multiply the exponents. So this is 3 to the negative 1 times x, or negative x, equals 3 to the 1. Now I can cancel out those 3's, giving me negative x equals 1. And then dividing both sides by negative 1, I have x equals negative 1. So that's going to be r going in spot 3. For this next one, I'm going to use a common base of 5. 5 and 25 are both powers of 5. This 25 is really 5 squared, so I'll have 5 squared to the x, which I can then multiply the 2 in the x and write 5 to the 2x. Now I've got a 5 on each side. Let me cancel those, and I can now write x plus 2 equals 2x. If I subtract x over to this other side, I have 1x equals 2. And that's going to be my answer, letter H, going in spot number 4. For number 5, I have 8 and 16. Those are both powers of 2. 8 is really 2 to the 3rd, and I'll leave that 2x out there. 16 is really 2 to the 4th. Let me multiply the 3 and the 2x together, so that's just 2 to 1 power, 2 to the 6x. And now that I have just a 2 on each side, let me cancel those, and I can write 6x equals 4. Dividing both sides by 6, I have x equals 4 over 6, which I can reduce to 2 over 3. That's going to give me E, which I will put in spot 5 over here. On this one, number 6, we have a 1 over 27 and a 9. The common base between those is going to be a 3. 1 over 27 is really 3 to the negative 3, because this is really 1 over 3 to the 3rd. So I can write 3 to the negative 3 to the fourth. 9 is really 3 squared, so this can be rewritten as 3 squared and then a 2x outside of parentheses there. Let me clean up each side by multiplying my exponents now. On the left side, I've got 3 to the negative 12. And on the right side, this is going to be 3 to the 2 times 2x, so 4x. Now that I have a 3 and a 3 for my bases, I can cancel those and just write the exponents. Negative 12 equals 4x. Dividing both sides by 4, we have x equals negative 3. That's going to be A right there. So that's going to go in spot number 6 right there. For this next problem, they got a little bit weird and gave us a decimal, but we can definitely rewrite the right side as a power of 10. This is really 1/10,000th right here if we say the word. So that's 1 over 10,000, 1 over 10 to the fourth, or we can write this as 10 to the negative 4. Once we do that, we can cancel out our base 10s, giving us just x plus 3 equals negative 4. And then I just have to subtract 3 to get x by itself, so that's going to be x equals negative 7, which is right there. That's w, so that's going in spot 7. Negative 7 in spot 7. Nice. Number 8 is not so bad as far as these go, based off the ones we've seen earlier. We clearly have a base 7 here. There's nothing else that goes into 49. So 49 we can rewrite as 7 to the second, and then we have that 8 out there. So we have 7 to the 2 times 8, 7 to the 16. 7s can cancel out. We just have x equals 16, and that's it for this one. So 16 is going to be A. We got a lot of A's here. That's going now in spot 8. So after question number 8, this one seems like we're kind of going nuclear again. These are some crazy bases that we're dealing with. So 4 and 9, if I put those together, that could be a 2/3 that we used a power to get this. And 2/3 would also get me 8 over 27 if I keep multiplying it together. So over here on the left side then, using a common base of 2/3, I can rewrite this as 2/3 to the second, and I'll have that x minus 2 still lingering about, ready to get distributed. Over on the right, 8 over 27 is really 2 over 3 to the third power. Now let me clean up the left side by multiplying those exponents. That's going to be 2/3 to the 2x minus 4 if I distribute that. Now I can cancel out those bases of 2/3 and rewrite this as 2x minus 4 equals 3. And that's actually a lot nicer now that I've got those crazy bases out of there. So if I add 4 to the other side, that's going to be 7. Dividing by 2, we have 7 over 2 for our final answer on this one. That's going to be S going in spot 9. For number 10, we've got these kind of smaller numbers here. This is definitely going to be a base 2 for our common base. 1/2 I can just rewrite as 2 to the negative 1. Now let me clean up that left side by multiplying the exponents. So we'll end up with 2 to the negative x plus 2. Be careful distributing that negative. Common bases of 2 can cancel, so we have negative x plus 2 equals x. Add this x over to the other side. That's going to be 2 equals 2x. And then dividing by 2, we have x equals 1. So that wasn't so bad. That's going to be an E right there, going in spot 10. Number 11 here is a bit much. We've got some pretty crazy fractions going on there. So let's think about this with common bases. We have a 64, a 125, a 25, and a 16. Now the 64 and the 16, I think those have got to go together in some way. Those are both powers of 2 for sure. They're also both powers of 4. I'm going to go with 4 because then I have smaller exponents to deal with. 25 and 125, those are both powers of 5. The issue here is that things are a little bit upside down on one of these fractions. So I'm going to have to take that into account as well when I rewrite these. So let me rewrite 64 over 125 as 4 over 5 to the third power. Those are both third powers of 4 and 5. And then over here, I want to write this as a 4/5, instead of a 5 over 4, so I'm going to need a negative exponent. I'm going to rewrite this as 4 over 5 to the negative 2 power, and I still have that x out there. Don't want to lose that. All right, now that I've rewritten things with common bases, let me clean up by multiplying these exponents. So on the left side, we have 3 distributed to 2x and negative 8. That's going to be a 6x minus 24 for the exponent over there. On the right side, we just have negative 2x for the exponent. Now that I have a single common base of 4 over 5, I can cancel those and rewrite this as 6x minus 24 equals negative 2x. And then if I subtract 6x to the other side, that's going to be a negative 8x, or I can add the 2x over here, giving me a positive 8x, and add the 24 over there, either way. And then dividing by 8, we end up with x equals 3. So that's going to be L going in spot 11. Now we come to our final boss battle for common bases here. I notice on the left side that we have the same base being multiplied together, so I can actually add those exponents and just merge that into 2 to the 3x plus 5x, or 2 to the 8x. On the right side, conveniently, 16 is a power of 2, 2 to the 4th. So now I can just cross off those bases and write 8x equals 4. Dividing both sides by 8, we have 4 over 8, which reduces to 1 over 2. That's going to be F right there. That goes in spot 12. Now we're going to solve this riddle. We've got all the blanks filled in. So why was Papa Shoe mad at his son? Because he was a loafer. A loafer is a kind of shoe and somebody who's just kind of hanging about and not getting a lot done. So till next time, Mr. Sutton signing off.